and the other we need to finish the activity last class. We like from the problem definition till the model building. Okay. So before the 9 o'clock, you need to hand in your 0.5. If you can finish on time, then maybe you can choose 1 or 2 groups to share their what they are due during the class activity. So the first things we just briefly review the theory of the problem. Okay. So first one, what you need to know is the problem solving models. So I think the model I like the most is on the left side of the PowerPoint file from the conceptualization, specification, solution finding, and decision making, then implement and evaluation. So most of problem solving process are something like this. And also, EMAI is very famous problem solving models. Start from problem definition, data measurement, analysis, improvement, and control. Okay. So I think there are still a lot of problem solving models. Okay. Then we skip for that. And what you need to do, you need to know. Sorry, too fast. Okay, so what you need to know is the process, how to translate the real world problem into your problem population. You start with the step 1. You need to know the real problem. Normally, these problems are unstructured. Then you try to make the problem structured so that you can do the formulation. Then you translate your real problem into the system point of view. Go to step 3. Once you finish the system construction, then you build a conceptual model. When you build a conceptual model, then you can use like a simulation software or mathematical modeling or a lot of kinds of the models to solve the problem, to form a problem formulation. Then, when you finish this, you do some analysis by your model. Then you can compare your model results with the real result to do the validation. Then you will know your problem will be solved or not. Then maybe you can do some improvement to make your problem ease the problem. Okay. Then I think this diagram is very good for defining your problem. When you have a problem, normally there is a gap between the existing situation and desired situation. Okay. For example, like your grades, maybe you have your grades is not very good for some certain of the subjects like calculus. Okay. So when you have a problem with your grades, then you say, okay, I can sacrifice my rest time. Then I sleep less. Okay, then I want to improve my grades from the 40 to 90, for example. Then the 50 grades become your gap. Then you need focus on this gap to take action. For example, you need to shorten your sleep time, or you need to increase your study time, and so on. Maybe you need to consult your professor or maybe some classmates who have better grades than you. Okay? I think this one is very important, and I will put this question, of course, in your midterm. Okay? So you need to, according to your case description, then define a gap. Before you form this gap, you need to do the actual analysis, because who is the problem owner. In the system, there are a lot of actors in your system. So you need to choose your problem owner, then take their perceptions and bond the gap. That's you must do. Okay. Then you need to realize your problem is simple or complex. If your problem is simple, then the problem automatically solved. But if your problem is complicated, then you need to try to you need to try to categorize what your problem is. For example, according to the technology uncertainty of social consensus, you can divide the problem into 4 types. The first type is called tangent problem. Tangent means simple problem. Then, if the problem is a technical problem, then you need to try to improve the technology or some skill to make this uncertainty become certain. Okay, so you try to move the second category to the first category. Or if this problem is not technology, the technology is not so high, and you can easily to get some technology, but sometimes they don't have a common consensus. Then what you need to do is you need to take actions to make all the actors within this system to get the same consensus. Then reach they are like standing on one boat. Okay, then they can work together and make the social consensus become certain. Okay, then this problem will be the third category on 10 political problem, and you try to make 10 political problems to become 10 problems. Okay, and the most complicated category is the category 4. This problem is on 10 problems. So social consensus is more, and the technological uncertainty is much. Okay, so this problem is normally maybe happen in the future, but maybe now some people already aware of this very important problem happen in the future. So someone maybe use the issue paper, try to point out there is a problem there and try to make this problem become easier to solve. Okay, so I think these are all you need in the midterm exam. By the way, I think you need also this kind of terminology you need to know. What holds equal contrastivity or much contrastivity according to the program is well defined or not, according to the program is structured or not, according to the program content is closed or open, according to the priority versus time. If the problem is static or dynamic, or the content is static context or dynamic content, or you can solve this problem by scientific approach or practical approach. And also, this problem is belong to the individual problem or collective problem. Okay? So this kind of topology you also need to know for analyze your problem. Okay. So all of this one is terminology you need to know in the midterm exam. Okay, and the next one is see the method analysis. Okay, so why need active analysis? One of the most important reasons is the social issue is so complex and involves a lot of different parties. So everybody has his point of view. Okay? So, okay. So what we need to do for the after analysis, what is the step for that? The first one, you need the initial problem formulation. Anyway, you need the initial problem formulation. According to the gap, you have the first definition of the problem. Okay? Then you list a group of actors which are involved in this or problem. Okay? And list their resources and determine their perception, determine their goal and interest. And then try to find the consequence if they are the problem owner. What is the existence output? Okay? Okay, so you need to list this table. Okay, the first actor. This is the problem example comes from the transportation department in the Netherlands. They want to build a bridge for the high-speed rail train. Okay, so the actor, maybe the Ministry of Transport, they have the resource or budget and the legal power. And what is their interest? What is the problem perception and the objective? So you need to, according to your gap, to list all of this. Then you will know who is the problem owner. For example, if your problem owner is the government, so everything you need to focus on the government. The performance indicators are according to the government. But if your problem owner is Netherlands Railway, then you must consider maybe benefit, maybe cost, and the other indicator for the system. If the problem owner is resident, maybe you need to consider environmental issue within your system. Okay. Okay, maybe you need to know the network analysis. I think I didn't mention before this class, so maybe I just talk about how you determine who is the problem owner. You have the actor 1, actor 2, you actor N. But how can you define their problem owner? They can according to their dependency, okay? According to their resource, relation, power, and dynamic. Okay, something like this one. Okay? So if two actors, you can compare their importance or not. Okay? Importance or not. And they can be repressibility with the low or high. Then you can know these two are dependent or not. Okay? So according to resource, they have important resource. They can replace. Maybe actor 1 may replaced by actor 2, which means actor 2 is more important than actor 1. Okay? So you can see the lower table here. You can see the lower table here. Okay? Then you will see the actor 1 compared to actor 2 are high dependent, which means the actor 2 is more important than actor 1. So if we have only 2 actors in the system, then we say that we will choose actor 2 as a problem owner. Okay? And if actor 3 and actor 1, they are independent, they are not have any relationship with each other. So if you choose actor 1, you don't need to consider actor 3. Okay? So according to this table, you can determine who is the problem owner, who is the other stakeholders. Okay? Okay, that's all. Any problem about the network analysis? Okay, maybe let's stop here. Do you need an example for this one? Okay, so maybe I use the example for this slide. Okay, for example, we have the Ministry of the transportation and the Netherlands railways. Okay. Then, if we want to know which one is important, then we according to the resource. Okay. The government has the legal power. The government has the budget. Okay. But the Netherlands railway, they have knowledge, they have the manpower. But you can think about that. If the government can make the law to force the Netherlands railway to obey their law, the answer is yes, right? So when you do this one, you say for the government, right? For the government, compared to Actor 2, oh, sorry, maybe here. They have important resource here, right? And you can think about that. I can make a law, but if the government has knowledge to build a high-speed bridge for the train, okay? Yes or no? The answer is no. So can Actor 2 can replace by Actor 1? The answer is no. Okay. Miss Google. And you can try to see if the government is high responsibility by other actors. The answer is no. But if we consider residents, okay, we have a lot of residents. Okay, they have different needs. Okay, if they have power to make a law, the answer is no. Right? If they have knowledge, the answer is no. So Actor 3, if the Actor 3 is resident, okay, so they maybe can replace by the Actor 1 and Actor 2. Okay, when the issue is for the law issue, then it can be replaced by the government or the railway company. If the issue is related to the railway construction, then the government is replaced by the railway company, and the residents can replaced by the company. So according to this conclusion, which one may be the potential proper owner for this system? I think the railway company will be the proper owner for the system. Okay? So you can use these two dimension tables to define who is the proper owner. Okay? So this one is very important. Then according to the proper owner's perception, you need to redefine the gap, right? You need to redefine the gap. Oh, sorry. I'm not sure. Yeah, this one. Okay. According to the proper owner, maybe you need to redefine the gap. Then the scenario or actions will be totally different from your initial formulation in the very beginning. Okay? So this is the first step. You need to define a problem. You form a gap first, then you make an actor analysis, and you redefine your gap according to the new problem owner. Then you do like a circle and circles and circles. Finally, you will know what is the problem in the system. Okay? Then, when we finish the gap, the next step is we try to make a system. Because now we want to build a model, then we need to build a system diagram and maybe IDF 0. Because now we try to use the simulation software vaccine to build a model. So we need to the IDF 0. Okay. So we start from the system diagram. The system diagram normally has a block. Okay, has a block. here with the dashed line means the system has an invisible boundary. When you have a problem, you need to define the boundary first. For example, when the problem owner is the railway company, so what is the system boundary for this problem? Maybe it's just a focus on the construction site. Okay, the system is very small, only in the construction site and some environment, maybe neighboring, will be influenced by the air pollution, water pollution, and so on, maybe noise or something. So very, very small size. But your problem owner, if the problem owner is government, so the system boundary will become larger because they want to maybe make a general law to let everyone to obey the law. Then the system will become stable. Okay, so when you define a gap and try to find the system boundary, after the system boundary, then you need to determine what is your output and what is your input, and what is the environmental influence to your system. Okay, you need to know the factors which will influence the system. For example, like weather, right? Weather is a very important issue now. And also maybe the population growth or population decrease. Like the system, like the education system in Taiwan, the population is very important, right? Now there's no kids. For you, for the younger people, you don't want to have a baby, right? You just want to be a big double income, no kids, right? And the double salary without any kids. Because kids will destroy your life. So maybe you don't like to have a baby. I don't know. Okay, so we build a system. And this is the other system formulation. You have an external factor like scenario. We have scenario 1, scenario 2. For example, if our problem is the population will increase in the near future. So what is the scenario? The government maybe gives some allowance to or compensation to the father and mother. Says every month the government will pay you 5,000 NT dollars. Then you can have this money to raise your kids. Okay, so this may be the scenario 1. And maybe the scenario 2 says, okay, the government will not give the compensation for the father and mother, but they can build a very safe education system that kids start from the 2 years old to 12 without any, they can just go to school for free. Okay, maybe this is the second scenario and so on. And you will see under this scenario, there will be some outcomes related to this scenario. Okay, and also you have this scenario, then maybe you can do something, change this system called tactics. For example, you say the government wants to give the newborn baby's father and mother $5,000. So what is your action? Maybe say, okay, the government needs to ask for more tax from others because maybe they don't have money to give to the newborn baby's father and mother. Okay, so they can do something to change the system to make this scenario become reality and really change the system. Okay. Okay, so this is an example for the whole system. Okay, and this is system for what? Or maybe environmental issue, I think. Okay, water supply or something. And this is for CO2 emission system. Okay, so this kind of system basically is very large. Okay, the activity that's the lecture is trying to let you to build a bank system. So it's very small, and you already know the system boundary is bank. Okay, so you try to find the what is the gap, what is the product owner within this bank system, and try to build some subsystem. Like definitely you need to have an information system, right? Subsystem in the bank system, and also you need to have a personnel subsystem in your system, right? Bank system, and maybe you need to have a quality check for service system in your bank system and so on. And within this system, they have interrelated with each other. So you can make maybe information subsystem need to give the support for the personnel system. Okay, and the quality information system need to give support to the quality check system. And quality check have a power to the personnel system and so on. Okay. Okay. So, okay. I think this definition is nice. Okay. You have the input, external factors, output, and tactics. And within the system boundary, you have subsystem and interlink with each other. Okay. So maybe you can use this as a paradigm to draw your system diagram. Okay. So SADT, which means the IDF 0. Okay. So IDF 0 is for flows, for the process flows. Okay. For the system, it's just a system. There are subsystems. But within this system, what is the flow for the system? Okay. What is the action? What is the scenario? It depends on the IDF 0. So when you have a system, then you build the IDF 0. After the IDF 0, then you build your branch model and do the analysis. And try to see if you then the gap becomes smaller or not. You can do the discussion according to your simulation model. Okay, so the rule to draw the IDF 0 is something like that. You have the 4 arrows. From the left side is the input, okay? Left right hand side is output. And the up side is control. And the down side is mechanism, okay? So, okay, so see the rectangles represent activity. For each block is activity. In the bank, what is the activity? They will open the account, is an activity, right? They sign the document, is an activity. So you are beginning with a very large activity, like bank activity, okay? Shading account department activity. Then you break down the activity into different sub activity within this block. Okay, so you can define like this. Okay, QDEP is an education institute. So the main block A0 is educate. Okay, for the input is high school graduate and university graduate. What is the output? Output is engineer or PhD. Okay, so what is mechanism? You can see maybe laboratory, personnel, classroom, right? Information system and so on. Okay, and what is the control to make this all make this activity transfer the input to output is university role or budget, okay, or project, okay, or outside education department standard or something, okay. And then, if you, from other point of view, to treat the QDEP as a research institute, then the input-output mechanism and control will be totally different, or the same or different. Okay, so this is another example. You have a main activity called import oil products in the bank system. Maybe you say we have account service, right? We have provide bank account service. Okay, then you have a customer as an input, and the output. What is output? The customer with satisfaction, right? Happy customer. Okay. Then for the mechanism for the bank, you have an information system. You have a banker. Maybe not banker. Counter servant. Okay, you have counter servant, or you have a manager, right? You have a manager. And what is the control? For the bank, there should be some regulation, or there is some government law will control the whole bank system, whole bank activity. Okay. Then you break down the A0 from the A1 to AN, right? So according to our case description, we have the person go into the bank. Then this person, this customer, maybe they want to do the NT dollar service instead of the foreigner currency service. So more than 50% activity maybe go to the NT dollar service. So we just focus on the NT dollar service for our system. Okay. Then we break down the activity into A1, A2, and A3, and so on. Okay. So what you need to do is you try to from the 0 and break down the activity to A1 to AN. Then within A1, for example, A1 maybe the NT, okay, NT service, right? Then within NT service, you have a pay open account. Maybe you have like a pay the electricity or water and so on. Okay, you have a different activity. So you can break down the A1 to A11, A12, and so on. And for the this block also have the input, output, control, and mechanism. Okay, and remember that you can each block at least you need have a control, output, and a mechanism. The input, you can have input or not, it doesn't matter. But definitely you need to have a control mechanism and output. Okay, so finally, we go to the class activity. Okay, so according to the, I just mentioned, start from the very beginning, how we define a gap. What is the property of the problem, right? Then you need to define the problem owner and reformulate your problem according to the actor analysis. Okay, then you really define the problem. I still need like just 5 minutes. Okay, according to this case description, then what you need to do is you try to do the actor analysis and define who is the problem owner according to this the two-dimensional table, and try to do the network analysis. And you can find the dominant problem owners and try to find the end objective and the performance indicator. Because this one is also for your system diagram and the IDE at 0. And then you must know what is the really the problem is 10 problem, unten problem, unten technical problem, unten social problem, or unten problem. Okay, I think this one may be the unten technical problem or unten social problem according to your analysis. So you just explain why this problem belongs to this category. And use the system diagram to determine your system. Okay? Then do the ID equal 0. Then according to the ID equal 0, then build a graph team. And then build some scenario, means your action. How can you improve the performance indicator of the whole system? Okay, you need to make your gap as small as possible. For example, if the utilization of the step is very high, add more steps into your system. And you say, okay, now we have 5 people, but in total we need to 100 steps to solve the problem. Okay, but we don't have enough money, so what we can do is we try to still keep the same utilization, but maybe we educate them to have a better skill to provide a better or have a quality or faster service like drive-through. Okay, well, that people to go drive-through to the bank, not really go into the bank. Okay, maybe this is another solution for your bank system. Okay, that's all. Any problem? And then now I think is almost 7:50. So you have 1 hour and 10 minutes to finish the PPT that I need. Okay, so let's start. Okay, if you have any question, just ask me or the assistant behind. Okay.